Quick headlines before the intro. Today's AI news is not a normal model leaderboard day. It is an infrastructure day. NVIDIA says Vera Rubin is ramping into full production for agentic AI factories. NVIDIA and Microsoft are pushing DGX Station for Windows as a desk-side system for frontier-scale local agents. TSMC is bringing NVIDIA AI into semiconductor fabs for lithography, simulation, defect inspection, and operations. NVIDIA also introduced Alpamayo 2 Super, a 32 billion parameter reasoning vision language action model for Level 4 robotaxi development. And on the robotics side, Isaac GR00T now has an open humanoid reference design for academic labs. The theme is simple: AI is moving from chat boxes into factories, fabs, cars, robots, and enterprise workstations. Receipts up, hype down, let's lock in.
Powered by artificial intelligence.
The lead story is Vera Rubin. NVIDIA's announcement says the Vera Rubin platform is ramping into full production to power agentic AI factories worldwide, with production shipments set to begin starting this fall. That wording matters. This is not just another slide in a future roadmap. It is NVIDIA telling cloud providers, AI labs, server makers, and enterprise infrastructure teams that the next generation of AI factory hardware is moving into manufacturing scale. The release frames agentic AI as a new kind of workload. One prompt can turn into a long chain of reasoning, retrieval, tool use, context memory, and response generation. That means the system is not only serving a single answer. It may be coordinating multiple model calls, search passes, tool executions, database reads, code runs, and policy checks. The hardware implication is brutal. If agents become the default interface, token demand grows, memory demand grows, networking demand grows, and security demand grows. Vera Rubin is NVIDIA's answer to that pressure. The story is not just faster chips. The story is an entire production stack built around agents that run longer, touch more systems, and need lower cost per useful result. The other important piece is the partner list. NVIDIA names major system builders and infrastructure partners across servers, storage, networking, and software. That tells us the AI factory market is becoming more industrialized. The industry is trying to move from custom cluster projects into repeatable systems that can be manufactured, validated, deployed, and operated like a product. If this works, the bottleneck shifts. It becomes less about whether one lab can build one monster cluster, and more about how quickly whole supply chains can repeat that build across regions, clouds, and sovereign deployments. For viewers, the takeaway is this: agentic AI is pushing infrastructure into a new phase. The models are only one layer. The real battle is the factory that runs them all day without falling over. The second story is DSX, and it is the one that makes the infrastructure theme clearer. NVIDIA describes DSX as a platform for designing, simulating, and operating AI factories. In plain English, building a data center for modern AI is getting so complicated that the data center itself needs a software stack, a simulation layer, and a reference design. NVIDIA's DSX page talks about reference designs: DSX Sim, DSX OS, Max LPS for power efficiency, DSX Flex for grid-responsive power orchestration, and DSX Exchange for connecting compute, energy, power, cooling, digital twins, and operation systems. That sounds like a lot because it is a lot. AI factories are no longer just rows of servers and a cooling bill. They are physical plants that need to optimize tokens per watt, manage heat, handle faults, coordinate power budgets, enforce security, and keep multi-tenant workloads running. The reason this matters is that AI cost is moving from model price into operational architecture. If two companies use similar GPUs but one runs them with better power management, better scheduling, better cooling, and fewer failures, the second company can deliver cheaper inference or more reliable agents. That is why NVIDIA is pushing the language of lowest token cost. It wants buyers to think about the entire factory as the product. This also connects to the energy conversation. If AI factories are pulling huge electrical loads, they cannot behave like ordinary web servers. They need to respond to grid signals, power events, pricing changes, and facility constraints. DSX is NVIDIA's attempt to make the AI factory less artisanal and more repeatable. It is not glamorous like a new chatbot, but it may decide who can actually serve those chatbots profitably. Story 3 is NVIDIA's AI Cloud Ecosystem Update. The company says its AI cloud ecosystem is expanding worldwide to meet global compute demand, reaching 6 continents with partners serving enterprise AI, startups, nations, AI labs, developers, physical AI, and sovereign AI deployments. This story is easy to underplay because it sounds like a partner roundup. But it is actually one of the most important strategic shifts in AI. Compute is being regionalized. Countries and regulated industries want capacity close to their data, their users, and their compliance rules. Startups want access that is not bottlenecked by one hyperscaler relationship. Enterprises want infrastructure that can support agents and digital workers without sending everything across borders. NVIDIA's blog also points to Nebius building a physical AI workbench that brings together technologies including Cosmos 3, Isaac Sim, and Isaac GR00T into workflows that agents can assemble. That is a big clue about where the market is going. AI cloud is not only rent a GPU. It is becoming a packaged environment for robotics, simulation, synthetic data, model training, inference, and agent orchestration. If a robotics company can go from simulated scenes to synthetic training data to evaluation to deployment inside one integrated cloud workflow, the compute provider becomes part of the product development pipeline. This is why NVIDIA keeps using the phrase AI factory. The cloud is not just a place where models run. It is a place where data becomes intelligence, intelligence becomes agents, and agents become workflows. The bigger implication is geopolitical. AI capacity is becoming critical infrastructure, and countries will increasingly care where that capacity lives. Story 4 brings the factory theme down to the desk. NVIDIA announced DGX Station for Windows, built with Microsoft and powered by the GB300 Grace Blackwell Ultra Desktop Superchip. NVIDIA says the system is designed to build, run, and connect always-on AI agents to Windows applications and workflows, and that it can run frontier AI models of up to 1 trillion parameters locally. The release says it is coming in Q4 from vendors including Asus, Dell Technologies, Gigabyte, HP, MSI, and Supermicro. The headline is flashy, but the real story is enterprise workflow. Most heavy AI development has lived in Linux data centers, while most business users live in Windows, design tools, engineering software, office workflows, file systems, identity, security, device management, and corporate policy. DGX Station for Windows tries to bridge that gap. The specs are also meant to signal that local AI is no longer just tiny models on laptops. NVIDIA lists up to 748 GB of coherent memory, up to 20 petaflops of FP4 performance, a 72-core Grace CPU, Blackwell Ultra GPU, NVLink C2C, and high-speed networking. More important, the release connects the workstation to a security story. NVIDIA OpenShell is described as a secure-by-design runtime for autonomous agents, using Windows security and containment primitives so policies are enforced at the system level rather than depending only on prompts. That distinction matters. If agents can use tools, open files, call applications, and run tasks continuously, please behave is not enough. Enterprises need containment, auditability, identity, and management. This is a big signal. The next wave of enterprise AI is not only about smarter models. It is about giving agents a governed place to live inside the operating system. Story 5 is the most industrial story of the day. NVIDIA and TSMC bringing AI into fabs. NVIDIA says TSMC is using accelerated computing and AI across lithography, transistor and process simulation, advanced process control, fab operations optimization, and defect inspection. The specific claims are worth slowing down for. NVIDIA says CU-Litho, its GPU-accelerated computational lithography library, delivers a 20 to 50% improvement in cost-effectiveness or cycle time compared with CPU-based computational lithography while maintaining the same cost of ownership. It also says CUEST, a GPU-accelerated electronic structure simulation library, gives 50 times faster chemistry simulations on average for semiconductor material design. On inspection, TSMC is using NVIDIA Metropolis and TAO Toolkit for automated defect inspection, including nanometer-scale defects. Why does this matter beyond chip nerds? Because the AI boom is constrained by chips, and chips are constrained by manufacturing complexity. Advanced nodes require intense simulation, mask design, process control, equipment coordination, and inspection. Every improvement in cycle time, yield, and defect detection can ripple through the entire AI supply chain. If fabs get better at using AI to make chips, then AI becomes part of its own manufacturing loop. That is powerful and also slightly circular. We build better AI chips with AI, then use those chips to build bigger AI systems, then use those systems to optimize more manufacturing. The sober version is this: none of this magically eliminates fabrication bottlenecks, packaging constraints, energy limits, or supply chain risk. But it does show that the AI story is now embedded deep inside the physical process of making silicon. The cloud begins in the fab. Story 6 moves from data centers to the road. NVIDIA introduced Alpamayo 2 Super, described as an open 32 billion parameter reasoning-based vision language action model for safe Level 4 robotaxi development. The release says the model reasons, plans, and acts across the driving stack. It also introduces AlpaGym, a high-throughput closed-loop reinforcement learning framework that trains autonomous vehicle models on the consequences of driving decisions in simulation, and OmniDreams, a generative world model for photorealistic closed-loop autonomous vehicle scenario generation. This is an important shift because autonomous driving is not just perception. Seeing the lane, detecting a pedestrian, or recognizing a traffic light is not enough. The hard problem is deciding what to do when the scene is weird, rare, ambiguous, or socially complicated. The phrase vision language action matters because it connects perception, reasoning, and control. A VLA model can, in principle, reason over what it sees, interpret instructions or scene context, and map that understanding toward actions. But this is also where caution belongs. A model announcement does not mean robot access are solved tomorrow. NVIDIA is pitching an open development stack for safer, scalable Level 4 development, not declaring that every city is ready for driverless deployment. The key contribution is the pipeline, real-world data capture, neural reconstruction, simulation, closed-loop training, generated rare scenarios, and in-vehicle deployment. Autonomous driving needs exactly that kind of pipeline because the road contains long-tail situations that are too dangerous or too rare to learn from casually. If Alpamayo helps developers test more edge cases before road deployment, the impact could be significant. The receipts say platform, model, and simulation tools. The implication is that physical AI needs reasoning plus synthetic worlds, not just bigger perception datasets. Story 7 is humanoid robotics. NVIDIA announced the Isaac GR00T reference humanoid robot, described as the first open humanoid robot reference design built on Jetson Thor and the Isaac GR00T open development platform. The newsroom summary says it combines a Unitree H2 Plus humanoid robot body, Sharpa Wave tactile 5-finger hands, Jetson Thor onboard compute, and Isaac GR00T software and workflows. NVIDIA also names research institutions including AI2, ETH Zurich, Stanford Robotics Center, and UC San Diego's Advanced Robotics and Controls Laboratory. The goal is to give academic labs a shared reference design so they can spend less time on bring-up and more time on skills, control, safety, and real-world validation. This matters because humanoid robotics has a reproducibility problem. If every lab uses different bodies, hands, sensors, compute, software, and data collection tools, progress is hard to compare. A reference design can make research more cumulative. It does not mean every lab will use the same robot forever, but it creates a baseline. The tactile hands are also worth noting because manipulation is one of the hardest parts of robotics. Walking across a room is impressive. Folding, grasping, handing over objects, using tools, and recovering from a bad grip are different beasts. A humanoid needs perception, language understanding, motor control, tactile feedback, simulation, and safe deployment. NVIDIA's bet is that the GR00T stack can become a standard development platform for that work. For viewers, the realistic takeaway is not robots arrive next week. It is that robotics is getting the same platform treatment as AI compute, reference hardware, simulation, foundation models, and shared tooling. The final story is a catch-up because it fits today's agent theme. Mistral released Search Toolkit in public preview on May 28, and IBM Research published a Hugging Face article today arguing that scalable enterprise AI adoption depends on agent logic. Put together, these two sources make a useful point: agents are only as good as the systems they use to find, judge, and act on information. Mistral's Search Toolkit is a composable framework for production search pipelines. It brings ingestion, retrieval, and evaluation into one framework, with BM25 sparse retrieval, dense retrieval, hybrid retrieval, and metrics like recall, precision, MRR, and NDCG. That is exactly the plumbing most RAG teams struggle with. If the retriever brings back the wrong evidence, the generator can sound confident while being wrong. If evaluation is missing, teams tweak prompts without knowing whether search quality improved. IBM's article pushes the same general direction from a different angle: agentic AI needs logic that improves quality, cost-effectiveness, and end-user trust. That is the unglamorous truth behind all the agent hype. A model can write fluent text, but an enterprise agent has to decide when to search, what to search, whether the evidence is enough, which tool to use, when to ask a human, and how to stay inside policy. This is why today's infrastructure announcements matter. The AI stack is turning into layers: hardware factories, cloud capacity, local workstations, operating system containment, fab optimization, physical world simulation, robotics reference designs, and search/evaluation tools. The winning companies will not just have a clever model. They will have the whole chain: data, retrieval, compute, security, evaluation, and workflow integration. That is the real story of today and yesterday. Final takeaway. The biggest AI stories from yesterday and today are not about one chatbot getting slightly better at a benchmark. They are about AI becoming an industrial system. Vera Rubin is about manufacturing the next AI factory platform. DSX is about designing and operating those factories like repeatable products. AI clouds are about regional capacity, sovereign deployments, and physical AI workflows. DGX Station for Windows is about bringing frontier agent compute into the enterprise environment where people actually work. TSMC's Fab AI story is about using accelerated computing and AI to make the chips that power the next generation. Alpamayo is about reasoning models and synthetic worlds for autonomous vehicles. GR00T is about giving humanoid research a shared reference design. And the Mistral plus IBM angle reminds us that agents still need search, evaluation, trust, and logic. So the question for the rest of 2026 is not just, which model is smartest? The better question is, who controls the stack around the model? Who can build the factory, power it, secure it, run agents safely, retrieve the right context, simulate the physical world, and bring the result into real workflows. That is where the market is moving. If you want the short version, AI is leaving the demo stage and entering the operating layer of industry. Subscribe to UGTP for AI news with sources on screen, and check the description for every primary source used in this episode.